the general form of quadratic is ax squared plus bx plus c. I know they call it general form, and then they call standard form a times x minus x squared plus k. We really normally call this vertex form. And guys, as long as I can ever remember, we've always called this what? Right? Standard form of quadratics, ax squared plus bx plus c. But I understand it is a general form, right? That is technically the general form, basically because of the conic section, right? When you talk about parabolas and all that. So, but the vertex form is really what we call the second equation. Is everybody with me on that? So you're going to be able to take a quadratic and you're going to be able to find the vertex of it, and you're going to be able to tell whether it opens up or opens down, and what the axis of symmetry is, and so forth. So if you had one of those handy-dandy TI-36X Pros calculators, you could type that thing in under the PolySolve, and it will give you where it crosses x-axis, both points, and then you keep arrowing down, and it will go and give it to you in vertex form as well. So it's a rather useful calculator. So it says where a and b and c are real numbers and a can't be equal to 0, the coefficient of the quadratic term can't be equal to 0, because if it is, it's no longer a quadratic term. That disappears. Then it becomes linear. And we do not want that. All right, so here's important formulas that you got to make sure you understand. H, okay? If we're talking about the vertex, we're talking about h comma k, right? That's really like an x and a y. Now, this h is negative b over 2a. Have you seen negative b over 2a before? Yeah, it's the first part of the quadratic formula, right? And then f of h means when you take that output and plug it in as the input of the function itself, you're basically taking input, finding an output, right? So you're going to find what h is and then plug it back into the equation to find output, which would be k. So that's what you're talking about here. Now, you'll look at horizontal shifts and vertical shifts and all that other stuff. Stretch factors there. Parabolas open up if the a, the coefficient of quadratic terms, is greater than 0. We normally say it opens up if a is positive, right? It opens down if a is negative, correct? And then we actually look at it in terms of an absolute value when we start to look at it. If it's stretching, right? Or shrinking or compressing. Okay. All right. They've got some, given the general conic, quadratic in general form, find the vertex, blah, blah, blah. It's this. We'll talk about it. We'll do so many, it ain't funny. We'll talk about domain and range. Don't worry about all this craziness here with the math. Okay? That's kind of convoluted anyway. Somebody really got happy and started nerding out way too much. They needed to go ahead and take a lunch break at that time. Yeah. Oh, they just filling up dead space. Look how smart I am. Gee. Yeah, they get paid by the page. Let's put the pictures on there. Don't worry about domain and range. We're going to talk about that. And we'll talk about all the other stuff. So let's just kind of get started. Okay, it's talking about x-intercepts, y-intercepts, so we'll just do it. So rewrite the quadratic function in standard form and give the vertex. Basically, take it and put it in vertex form, correct? That's really what they're wanting us to do. So, here we go. First things first, we got to find A and our B. So our A is 1, our B is 4. So our H is negative B over 2A. So negative 4 over 2 times 1, which is what? Negative 4 over 2, which is negative 2. That's our H value, right? Okay. Any questions about that? Note that when I substituted the B in, that I kept the negative on the outside and put a parentheses. Because that is your most common mistake that you'll make, is when B is negative, you'll end up just making that negative. One negative and not being a positive. Okay, so we're going to take this negative 2 and we're going to substitute it back into this equation. So negative 2 squared plus 4 times negative 2 plus 7. Ladies and gentlemen, that's 4 minus 8 plus 7. So that is negative 4 plus 7, which is, ladies and gentlemen, 3. So I have an H that is negative 2 and a K, it's okay. Tell me to slow down. It's okay. So I got H is negative 2 and a K that's 3, right? And that's really an ordered pair. Does everybody understand what the vertex is? Yes or no? That is where the transition points happen, right? That's right. It's either your minimum or your maximum, depending upon if it's opening up or opening what? Down. So you got to make sure you're solid on it. Okay. Any questions? No? I'm just going to stretch my legs. Okay. Yeah. It comes from the conic section, yes. Yeah, the parabola, the circle, the hyperbola, and the ellipse all are based upon H and K's. Yeah. And I'm glad that they did use H and K or something other than X and Y, so they'd have to do an X1 and Y1, because it's easier when you're given an H and K, whether it's a parabola or a circle, and you're using a point on the circle itself or a point on the parabola. It's a little bit easier to know where it goes. So a little less confusing, right? Okay, so I hate that they forced a, this is really what this is supposed to be, right? Man, I hate that they've done that, because look what's going to happen. Our A, this is our A, right? A is 1. That's the same A of the vertex form, right? So that's a 1. Minus, well, it's negative what? 2, right? I don't like this, because we're thinking, okay, that really should be X plus what? 2, right? But what they're trying to get you to understand is, when you subtract a negative, it's going to be a what? Positive. And if you remember, when we done vertexes on quadratics, the H value always changed signs when you put it in or took it out of the equation, right? Because of the X minus H. And of course, the K is the external. That's the vertical shift part, right? Then that would be 3. So we'd have negative 2 and what? 3 for a vertex, right? Note that this right here is really going to be what? Right? If you're looking at it from a traditional standpoint, y equals x plus 2 squared plus 3. There's your perfect square trinomial showing up again. Y'all remember that when we completed the square? When you have a binomial written, that's 2 factors are the same as a perfect square trinomial. Okay. Any questions on that? Determine whether there's a minimum or maximum value to each quadratic and find the value of the axis of symmetry. Well, the AOS, okay, is x equals h. It's a vertical line, right? And the vertical line is about the point that is the h value, which is the x value of that vertex, right? That's your folding point. It's like a line of symmetry, right? Axis of symmetry. So what we're going to do is we're going to find the h real quick. But before we do that, is this a minimum or a maximum? What do they mean by that? Which way is it opening? If it's opening up, then you have a minimum. If it's opening down, you have a maximum. Think about valleys and mountains. You'll be okay on that. So this is a positive A, so therefore it's going to be a what? Minimum. That joker's going to open up, and it's going to have a minimum, right? Now, I'm not sure about what they want for the value there. Find the value. Oh, h value, I guess. So h equals negative b over 2a. A equals 2, b equals 4. So the value is negative 1, right? The value of h, that would be what they want by the value. And then the axis of symmetry, x equals negative 1, right? Because x equals a number is the line or the equation for a vertical line. It has one variable. That variable tells you what axis is being crossed, and the number tells you where on that axis. And for these, x equals negative 1 means you'll have a axis of symmetry. That's your folding line at negative 1. It should lay you smack dab on top of it, right? Yeah? All right. Any questions on that? I think well, okay, let's do this. I put negative 1 because I was assuming that they were wanting the h value, right? Okay, so if they're not wanting the h value, then they're wanting the minimum or maximum, which would be a k, right? It'd be a k. So they either want a point or the y equals, right? So let's just go ahead and plug it in, just in case they want it the other way. We've got it covered, right? So that's 1 squared times 2 is what? 2 minus 4 plus 3, so it's negative 2 plus 3, which is 1. So if they're wanting an ordered pair, there you go, negative 1, 1, right? Huh? Oh, 13. That's 11. Right? So negative 1, 11, right? So R, y equals what? Depends on how they want it. You can either give them to it, I guess, if they say, okay, what the minimum or maximum, its value, then, yeah, that'd make a little bit more sense that they'd want that. Huh? Mm-hmm. I don't know. Maybe they didn't understand that there's only one quadratic function there. You got to think about, are these math people writing these? Probably not, because they're verbally or grammatically correct, right? Think about it. If you got a true analytical mind, you might as well pack it up and go to the house. They're not going to write it. It's going to be a funny book. You know, you have about 80-85% grammatical correctness there. But you'll run across a done. I done that, right? Right? Yeah, think about that. Okay. Y'all ready? Yeah. Give your brains a little bit of time to debrief. All right. So they want you to find the coordinates of the vertex. It indicate whether it's the highest point or the lowest point of the graph, and then the axis of symmetry. So what we're going to do is we're going to stop. We're going to give you about a minute head start, and then I'll start and we'll compare, okay? And they gave us a fraction, didn't they? Gotta hate that. Man. But if you do it by hand, I promise you it won't be quite as bad. So I got 1/2 and 3. Do y'all agree? Yeah? Sweet. Like that. All right. Is it the highest or lowest point? Why are you saying highest? Because the coefficient of the quadratic term, is negative, so therefore it's opening down. So that would mean that this is the way it looks like. So that would be a highest. And the axis of symmetry is x equals h. So x equals what? 1/2. How we doing?
Where does the b come from?
Oh, right here. This is ax squared plus bx plus c, right?
Right.
Yeah, so the b is -4. Or +4, sorry. B is +4, A is -4. Right there.
What do you plug that into?
Right here. Because I'm trying to find the vertex. In order to find the vertex, I have to have h. And h is -b over 2a. Right? And once I find that, and it came out to be 1/2, then I plugged 1/2 in for the x's to, here's an input, find me an output based on that input, right? And then it gave me an output of 3. Yeah, the h equals -b over 2a. That's something I'd make sure I knew. Okay. All right. Any questions on this? Okay. I'll give you enough head start. No questions off these? Me neither. It's okay. No, it's basically the same thing. It's going to take a general form and ask you to put it in standard, which is really vertex, right? So you're going to have to do h equals -b over 2a. And then substitute it back in. So you're just converting from one form into the other, and then it's asking you a couple of questions. Opening up, opening down, maximum, minimum, highest, lowest, and then what's the axis of symmetry? That's exactly right. It's either mountain or valley, right? X equals h, right? So the h value is 1/2, so x equals 1/2. Okay? I'll just watch it about 16 times. You'll be okay. Well, it's opening which way? Down, because that a is negative, right? All right, determine the domain and range of the following quadratic function in interval notation. Well, first off, guys, the domain for every quadratic that we're going to come into contact with is always going to be this. negative infinity to positive infinity, period. Okay. The only things that are going to be things that trip you up is, well, it's opening up, it's opening down. So there's a maximum or a minimum, right? So how do we find that? Well, they've given you the vertex form, right? So here's a, here's x minus h squared, and here's k. And if you remember, I said if you pull it out, that the h value has to do what? It has to flip or change signs, right? So that positive 6 has to become a what? And then the k is the number afterwards, and that's negative 7. So the vertex on this is negative 6, negative 7, right? You agree? Now, which way is it opening? Down, right? So the lowest point is who? Negative infinity, right? What's the highest point on the y? Negative 7, is it not? So it's a parentheses, and it'll always have a bracket. You'll have a parentheses for the absolute value, not the absolute value. You have a parentheses for the infinity or negative infinity, period. And then the other number will get a bracket because that is a fixed point, right? And it's included. Any questions on that? How we doing? Right here. How do I get a positive 6 if this is x minus h squared? How do I get the positive 6? Only if the h is what? There you go. So when you pull it out, do what now? It's what they call standard form, right? But it's really vertex, right? We all know it by vertex. Let's just call it what we all, but they're going to revert to it as standard. And then general is normally what we call standard, which is ax squared plus bx plus c. But they call it general, right? Yeah. It's like what came first, the chicken or the egg, right? Chicken. Egg can't survive. It has to be incubated. Think about it. Ma'am? The points for attempting. Only if the attempted part's correct. Yeah. Only if the attempted part's correct. Sorry. Just remember, when in doubt, do what? Pray. Good. Yeah. There's one thing that's going to change in here, your prayer life is, right? Sorry. Like, whoo, divine intervention. Well, it's never too late. So, I moved that comma down so that it didn't look like it was negative infinity and negative infinity, right? So, okay. Let's do another. I had that comma way too far up, so it could appear like it was negative infinity and negative infinity. So I erased it, moved it down so it was in the right location. Okay, guys. Determine the domain and range of the following quadratic function in the interval notation. All right. Domain. That's like a rubber stamp. Ching ching. Okay? You got to make sure you understand that. There. Now, what are we going to do? Which way is it open? Let's just talk about that. It's opening up, right? So, man, I know that right there is so, right? Y'all see that? I know the highest point. If it's opening up, baby, the highest point is infinity, right? So how am I going to figure out what's the lowest point? What would the lowest point be called? Your vertex, right? Which is an h and a what? So what's your h value? Negative b over what? Now, how do I remember these equations? Every time I work them, I write them down. It takes 2 seconds to do it, but the payoff and the dividends in your brain is tremendous. Here's your A, here's your B, here's your C. So we have minus 12 over 2 times 3. So that's negative 12 over 6, which is negative what? 2. So that's going to give me 3 times negative 2 squared plus 12 times negative 2 plus 13, now that I can see and count. So that's negative 2 squared is 4. 3 times 4 is 12 minus 24. Y'all see a pattern there? Did you notice that the first one and the second one, the first is always half of the second one, and the second one's opposite side? Have you noticed that? Really? Yeah, there's a pattern there. There is. Just be mindful of that. So if you don't get these right here to be half of one another, one positive, one negative, you've probably done something wrong. I got 1. So that's really, this joker's opening up, right? Right there. So that's negative 2, 1, right? Which would be what here? Right? And if you look back at it's saying K, right? It's saying K, comma, infinity, right? Y'all, if you look back on your notes, it'll tell you that back on the first couple of pages, right? Yeah. So forth. It will. But if you draw this right here, you'll be okay. Questions? Y'all good? Okay. Let's go green. Well, then went green. Let's go blue. Graph the parabola. Do not place any dots, then fill in the blanks about the vertex and the x-intercepts. Graph the parabola. Do not place any dots. Are y'all reading what I'm reading? How are we going to graph it if we don't put any dots? Lord help them. Off your computer screen? No. You can. Just you got a surface. So, anyway. Then fill in the blanks about the vertex and okay. So, guys, it's 2x plus 1 squared plus 1. So, guys, it's ax minus h squared plus k, right? So, if we're going to graph this, it's h comma what? H comma k. So, what's my h? How do I get a positive one? It has to be a what? Thank you. K is exactly what's there. Right? How we doing? So, negative 1, 1. Which way is this joker opening up? Up. Your A is 2. It's positive, right? 2 just means it's going to be a little narrow, right? A little skinny. It's going to be a stretch instead of a shrink. And then it's positive and it's going to open up. So kind of look at this. How are we going to then fill in the blanks about the vertex and the any intercepts? Oh my. Guys, I'm going to teach y'all something. The first change of any vertex, or not vertex, parabola, is should be the A. And that's 2 over 1, right? So up 2 over 1, up 2 over what? Now, I'm going to graph this thing. Y'all know I am. Right? I'm about to graph it. Just to prove. if you've done a lot of theory with quadratics, that should hold true there. If you've looked at the incurrent rate of change and filling out stuff. Don't. Two over one. Yeah, 2 over 1. Up 2 over what? Huh? That's A. A is the first rate of change. Should be. If it's in standard form, which is really ax squared plus bx plus c, that's true. Should hold true for the vertex form. But we're going to validate that. You ready? Yeah? Okay. Man, I love my graphing calculator. Sorry, I just like to nerd out. Okay, here we go. So what is the problem? 2x plus 1 plus 1, right? True. So y equals, let me get the clear. 2x plus 1 squared plus what? Get on up in there. Plus 1. Yeah? All right, so let's graph it. Hey, look at that. Then let's just zoom 6. That's zoom fit, right? There you go. So you can't really tell a lot from that, but you can if you look at a table, right? So I like tables. You like tables? I like tables. Here we go. So we're going to delete those, and let's see. We said it was what, -1, right? So let's put -2, enter, -1, enter, and 0, enter. Ladies and gentlemen, it should be up at 3 and 1 and 3, right? Y'all agree? Yay or nay? Okay, good. Let's go back and look at our graph. Hey, that's exactly what we got, right? So yeah, the A does follow suit on the vertex form as well. Y'all did know that A was always the first rate of change, right? No? Really? Man. That's pretty cool. Okay. You good? Do we got to answer anything down here? Yeah, what's vertex? Yeah, we got to do that. -1, 1, and that's 0, what? 3, right? Yeah. Now, how do you find the y-intercept if they are, you draw a blank, right? Well, how do you find it? Well, let's look. Y equals 2 times 0 plus 1 squared plus 1, right? Because when I want the y-intercept, x is what? That's right. So that's 2 times 1 squared, which is what? 1, and 1 times 2. So that's 2 plus 1, which is what? That's 3, right? All right. Any questions? So you can always do that. That's always a go-to right here. Yeah? No? Oh, I don't know. How you go place dots and graph something if you don't place dots? I don't know. Okay. X. Find the vertex and a convenient point. Convenient point to sketch the graph of the following. What's convenient, right? Now, my question is this. Y equals x squared minus 3. What form is that in? Which form is it in? You don't know? No? Well, there's not but 2 forms to choose from, right? You agree? Hey, Yeah, that's quadratic. But which form of a quadratic? Yeah. Oh. Which form? Come on. We said standard or what? General, right? So let's kind of back it up to a terminology that we have been using, right? Vertex form, or is it standard ax squared plus bx plus c, which they're calling general, right? Which one is it? Looks like a vertex form, doesn't it? Ladies and gentlemen, it's actually in both forms. When you have no linear term, you have both forms represented. Because here you go. If I want to write this in vertex form, what's this? It's already there, but I want you to think about this. All right? What does 0 do to it? Not a dab blame thing. Right? It changes nothing. 0, 0, right? And then if you look at it like this, well, I will tell you this. And it's only like this when the h value is 0. It's only like this when the h value is 0. You know what this number right here is? Anybody know what that number is? The what? That's exactly correct. And we didn't shift this left to right, so it just went straight down, right? And the slope on that a is 1 over 1, right? So over 1, up 1, right? Or up 1, over 1. So there you go. That's your 3 dots, right? Correct? A is 1. So that's really 1 over 1, which is changing y over changing what? X, right? Okay. Find the vertex. We found it. It's 0 what? 0, negative what? 3, right? Because the h value is 0 and the k value is negative 3. And then convenient point would be, okay, it's just taking a parent function, moving it down what? 3 units, right? Y'all remember shifting? Shift happens. So just remember that. Y'all good? Uh-oh. Guess what I skipped? That I shouldn't skip. 7 point what? Yeah, 7.1 is supposed to come before this. It's okay. Yeah, it's different. 7.1 is linear. It's okay. It's just some stuff. We'll go back and hit it. It'll be okay. I promise. Huh? Oh, but they looked at it and they put linear and then put quadratic in there. Right? I should have done 7.1 then 5.2. 5.2 is the last thing. And yeah, 5.1. Sorry, not 5.2. My bad. Well, I thought it was open, but yeah, it's okay. Listen, all we got to do is do elimination, substitution, systems. That's all that 7.1 is systems of linear. That's all it is. So, anyway. Okay. Man. All right. We'll get there anyway. Here we go. Use the vertex h comma k and a point xy to find the standard form of the equation of this quadratic. Guys, what are we actually solving for here when we put in all this? Huh? What's the one thing that it didn't give us? the a, right? Think about it. They gave us an h and k and an x and a what? That's exactly right. So the only thing that they did not give us was a, right? Y'all see that? Yay or nay? Yeah, come on. I'm going to plug it in, right? So here's my x and my what? And there's my h and my k. So -2 equals a. -2 minus minus becomes what? Plus, right? 3 squared. And the k is plus 0. So that's -2 equals a. Well, that's what? What is that? 1 squared plus 0? So that's really -2 equal to what? A. So that would be -2 x plus 3 squared. Do I have to put the plus 0? Nah. There you go. Yeah, this is a pretty traditional one right here. They give you h and the k and x and y and tell you to find a. Right? Sometimes they say here's your vertex and a point on the parabola. Write the equation. That's traditionally what they do. So. Questions? Anybody? All right, let's get into some word problems. The most famous word problems that you could ever do for a quadratic is this: projectiles. Okay? You're going to shoot something. You're going to use a quadratic equation. I don't care what it is. All right? Anybody study ballistics of things? Paths of bullets and whatnot? Like that, right? It goes up. Yeah. All right. Bullets. And then, when you're sitting on a boat way off in a sea and you shoot it something that way, it goes up and then it goes what? Down. It's a parabola. It's quadratic. So they're doing the math behind it. Huh? Do you know what that a sniper does trig in his head in a matter of seconds? Yeah. I couldn't hit the broadside of a barn. No. I am. But I couldn't hit the broadside of a barn not way off. Couldn't see it. No, can't see it. Out there it shakes. Yeah, that's not good neither. Right. Yeah, you got to be still, right? Breathing, all that stuff. I love it watching. Huh? Yeah, it's exhaling, right? It's on the exhale of your breath. So everything's out, right? Yeah, yeah, yeah. All right. The height of an object tossed upward with an initial velocity of 64 feet per second is given by the equation -16 t squared plus 64t, where h is the height in feet and t is the time in seconds. Find the time required for the object to return to the point of departure, meaning find its time that it takes to hit the ground. Okay. In theory, the time it takes to go up equals the time it takes to go what? Down, right? Does that make sense? So there's two ways to think about this, because you can all right, so right, that's ground. Yeah, go ahead and make fun of me. It was, but it's okay. All right, so that sucker's going up, coming back down, right? So all you're doing is -16t squared plus 64t equals to what? 0. What's its output? When do you want to know its output? That's 0. Folks, I have a quadratic term and a linear. Anybody want to know? Take a jab or stab or guess how we're going to solve this? Y'all remember? Oh my gosh, Lord, yes. Be still my heart. Factoring, GCF, right? No, not factoring like factoring GCF, right? You meant GCF, right? Factoring GCF. Yeah, I know you did. I know. I just have a feeling. All right. So when you factor out GCF, you either factor in a number, a variable, or the product of a number and variable, right? Well, both of these got variables, so we can at least do that, right? So can I factor out something at a number? So I'm going to factor out a negative 16t. That's going to leave me with t minus what? 4. T minus 4. So we actually have two factors here. Most people go, that's just that times that. No, it's two factors. So you take each factor equal to what? That's right. So that one is automatically what? Hey, that's when it started, right? And then, ladies and gentlemen, when did it return down to the ground? Now, my next question would be this. How long did it take to get to the top? Yeah, so how long would it take to get to the top? No. 2. 2 going up and 2 going down for a total time of what? 4. Right? In theory, yes, it takes the same. Would the acting against and the going with cancel out? Well, the initial velocity is 64 feet per second. If it's in metric, 32 feet per second square fits in what? Standard units, right? Yeah, 32 feet per second squared. Yeah, for sure. Because that's how they get negative 16. They go negative 1/2 g, the gravitational constant, right? Yeah, no, that's a positive, trust me. I have done more than I ever want to know about these equations. Okay, so just in theory, just understand, theory, that from here to here is 4. So it's 2 seconds to get to here, and then 2 seconds to get to where? Down there, right? That's only because it started where, folks? On the ground. On the ground. Now, if it started somewhere else, then that can't be true. You understand? Because if 100 feet up in the air, it takes less time for it to get to the maximum on that, right? So, yeah. Vertex. Yeah, up here? Yeah, I don't know. I don't know.
Yeah, in this case, probably.
Would it be? Apex?
I don't think so.
Yeah. Yeah. Oh, shaking his head, yeah. So 3 out of 3 say good. Or 4 out of 3 were okay with that. So alright, y'all ready? Y'all should really go back and listen to some of these videos. Yeah, you never get anybody like this right here again. I promise. Ever. Ain't it though? Lord help us. Sure enough. Alright. I put this on here just because I wanted a challenge. Is it one of we doing on the homework? Yeah. Yeah. These come straight from homework, right? Yeah, straight from it. Now your numbers will be different, right? But the approach or process will be the same. Well, why do I say that this is a challenging problem, guys? Because them numbers ain't pretty. Them things ain't pretty. They ain't. we're going to do it anyway. So a company finds it can make a profit, P dollars, each month by selling X patterns. According to the formula, P of X equals negative 0.002 X squared plus 5.5X minus 700. How many patterns must it sell each month to have a maximum profit? To obtain maximum profit, they must sell blank patterns. And what is the maximum profit? Well, X is the number of patterns, right? The Y is the who? Profit, right? Now, I'm using X and Y. That's really what? Well, it's really going to be my H and my what? K, right? Because they want to know what's my highest, right? Maximum. That baby's got to open down, right? Hey, it's opening down. It's got a negative 0.002. So here we go. A, well, I want that. Wapachaw. A equals negative. Yeah. So I don't know what that is. So that's negative 5.5 divided by 2 times negative 0.002. Ooh-wee. I got an H value of 1,375. Did you? Don't sure me. Girl, you got to know this. You got to know that you know you know. You know? So how many patterns are we selling? 1,375. Now that makes a little bit more sense, right? I mean, it's crazy numbers, but they come out pretty in the end. Now we got to take this right here, and we got to go, oh my. And we got to plug that 1375 in, right? Yeah, if we had this in mathematical modeling, we'd have it done lick because we can do it on calculator. All of it, right? It was wonderful. So let's do it. Negative 0.002, parentheses, 1375, right? Squared, plus 5.5 times 1375. Make sure I type in things in right. Negative minus 700. Shaboom. I have a K value, ladies and gentlemen, of $3,081.25. How do we do? Somebody please tell me they got the same as me. Y'all good? Huh? We got one more problem. That's it? On this? I gotta slow down. Not really. How we doing? Y'all agree? Got a couple of head nods. Yeah. Okay. All right. If you watch this video, make sure you understand we done 5.1 before we done 7.1, so it's out of order. Just be aware of that. All right. Solve the problem by writing and solving inequality. A rocket's fired from the ground level. Its height in feet t seconds after launch is given by 320 t minus 16 t squared. During what time interval is the rocket higher than 1024? Nope. Nope. Ladies and gentlemen. Can I do this? Are y'all okay with that? So you want to see how long it takes to get there, right? That's an output, right? 1024 would be, that's an output. That'd be like doing a horizontal line at that point, right? Do y'all agree? What? Yeah. Uh-huh. But look at those inequalities. Those aren't equal to, are they? Okay. So if it's higher at 2 and 5, if I put 2 and 5 there, I'm good. If it's 1024 at 2 and 5, I'm good. Because it's not equal to. It's greater than and less than, right? It's not greater than equal to or less than equal to. So therefore, if I put those designated points, I'm good, right? So if I set this equation to that output, and output's 1024, right? And I solve this crazy quadratic, which, how are we going to solve this crazy quadratic? How y'all want to do this? Will 16 going to 320? Yeah, sure will. We're going. We are. Anytime you go to solve a quadratic, you got to make sure that it's what? Yeah, exactly. Good job. Equals 0. So I'm going to take this over here. And then I'm going to do this. See if y'all agree with this. So I divide everything by negative 16, guys. I get t squared. Uh-oh. My calculator said something about memory. Minus 20 plus 64. That's minus 20t, right? Equals 0. What are factors of 64 when added together give you 20? How much? Look at you. That's awesome. So negative 4, negative what? 16, right? Because those add together to give you negative 20, but they multiply to give you positive 64, right? So t minus 4 equal to 0. T minus 16 equal to 0. So t equals 4 and t equals what? 16. So it'd have to be greater than 4, but less than what? That's right. That's when it will cross 1024. It'll be higher than at 4 and 16. Now we shot this from the ground, right? Right. So what's the spread between 4 and 16? 12. So if I went, that's 6, right? The highest point, the x value is 10. How did I do that? They shot this from where? 0, right? From the ground, right? So the symmetry, right? Correct? 4 and 16 gave me an output of 1024, right? So what's the distance between 4 and 16? It's an overall of 12. What's half of 12? 6. So if I go 6 in, I'm on the vertex right there. That's the x value, or h of the vertex, right? That would be 12. 12 seconds to get to the top. Yeah. Don't take my word for it. Okay. Listen up. Your brain is mushed. Okay. So we're going to stop right there. But we're going to talk about stuff. We got to talk about some stuff.